Yes.
So when you hear that word, you know recording has started. Now here we are looking at structure of materials that don't break easily. Those ones that do not shatter easily. Shatter means breaking or turning into pieces as easily as it can be. You get? Now these are the ones that don't shatter. The ones that don't shatter easily. Actually, they don't break easily. So an example of these things are called what? Plastics. Plastics. Okay. Now
Yes.
there is no plastic. We don't have any
They
plastic.
just bend, but they don't break.
Uh,
Shutterproof.
yeah. So here we have plastics. Plastics. Which plastic do you know came from heaven?
Hmm?
Any plastic you know that came from heaven?
None.
None of the above. So in simple terms, plastics are man-made. You get it? Yes?
Yes.
So
Yes.
if they are man-made, the common term they use for man, as long as man has combined some things to make it, they are called synthetic or synthesis. So something made through a process is called synthesis. That process is called what?
Synthesis.
Good. So the term they have used here, they are called synthetic materials. These are man-made. Plastics are synthetic materials. Synthetic means
Synthesis.
made by.
Synthesis. Humans.
Synthetic made by what? Humans.
Humans.
They are not found in nature. So
Nature.
human beings sat down and looked at different ways of making sure that they make the best use of things God gave them on earth. So in that process, they came up with a process or a synthetic way of making sure that the ordinary things God gave them, they can be utilized properly. You get it? So at first, plastics were made over years ago. Most of the
Over.
plastics, most of them, the ones we use daily, they were made years ago. So nowadays, what people do is they try to modify. They try to modify those things that existed long time
Plastic.
ago. Yes, to make other things. You get? Now,
Mm.
plastics of those days, most of them were discovered to be poisonous to human nature. Hmm?
Mm.
So when they are poisonous, humans came up with another way of making sure that they use these things. Like the lady pipes they used to use those days. They were removed from down. You find people digging down daily. They are trying to remove those pipes from down so that they
Mm.
replace them with the plastic ones. Okay? Because
Yes.
the plastic ones at least can stay for so long. They are not easily decomposed. Actually, they cannot change state. But the lead pipes were found to be disappearing from the soil after some time. They get mixed up with soil and they turn into soil. So that was the disadvantage of those whatevers. That's how plastics came in. Now we want to look at these properties of these plastics. Uh, okay, there is a statement here that says that they have become very important to us mainly because they are cheap to make and easily molded into different shapes.
Mm.
Molding comes from actually clay. Clay is the thing that you can mold easily and turns into any shape you want, isn't it?
Yes.
Yes.
Now, when it comes to plastics, plastics are also easy to mold, but at least you must get something you use for molding these plastics. Because for you to mold a plastic, it must
Mm.
be in a liquid state. You get it? And that liquid state of a plastic
Yes.
is quite very hot. Hmm?
Mm.
Now, you can't use
Mm.
a human hand to hold them. You have to make sure you pour in a certain container and then they cool in that shape. Okay? So now these are the properties. These are the properties. The properties of plastics. Now, They vary from this opaque. We looked at a color called opaque and we related it to a dark color down here. Do you see those balls on top?
Yes.
Yes.
These balls are dark. You can't see through them. That is the meaning of the word what? Opaque.
Opaque.
Ah. They vary from transparent to opaque. When something is transparent, is like the curtains we use at home. Most of them are transparent, isn't it?
Yes.
They allow light
Like
to
ours
pass.
here. To pass through. They allow light to pass through.
Okay, thank you. So they vary from transparent to opaque, and then they are hard to soft. Those are the characteristics of plastics. Do you know
Weak
any
to very strong
weak to very strong, heat resistant to
to
easily
easy to move.
melted? Okay, so
Yeah.
they do not conduct electricity. You know the reason
Hence,
as
are
to
you
why the plastics do not conduct electricity? Hmm? Don't plastics
they are
conduct
used
electricity?
as electrical
They are what?
Yes.
they are used as electrical insulators.
Yes, they are used as insulators. Insulators is like the wire we have at home. You see that wire?
Yeah.
Yes.
There is some,
They are dressed with rubber.
yes, that rubber is what we call a plastic. So that rubber doesn't conduct electricity. So we are going to look at the different types of plastics and then we shall get to know where those ones fall. So here they are saying they do not conduct electricity. The reason is, you can put it down, is they do not possess or they do not have free mobile electrons. You see, in electricity, there are electrons inside those wires. They are the ones that are responsible for conducting what? Electricity. In plastics, they are not there. You get it?
Yes.
Okay. So here, the properties vary from wire, from concrete and ceramics. Their properties are very different from properties of ceramics and concrete. We looked at ceramics. Let me go back and check properties of ceramics. Now, when you look at this, ceramics, it has several important properties which have been, which they have. So number one is it can easily be molded when wet. That is one property. That is ceramics, not plastics. When dry, it goes hard. Okay. Two, clay. If clay is heated on fire or oven, it permanently goes what? Hard. When clay, now those are some of the few ones. And then clay, someone is okay. We all mute our microphones. Then if you want to talk, you just raise your hand or you say something. Then you leave it there. We mute the microphones. Okay, thank you. So here, Austin,
Yes.
mute the microphone. Okay, there now we are free to go. So these are properties of clay. These are the properties of clay. So when you look at clay, this is what it has. It is structure. It can form a very hard giant structure, a very big structure. That's what we call a giant. You know those movies that have giants. I've forgotten one movie that has a giant human being, but giant is as big as you know. So clay can be made in that way. It has ability to make the giant hard structures. So this is an example of this very small piece of clay. When you add it up to others, they gave us the structure of a pot. Is it okay? So that is that. Now, when you come to which other element did they talk about? They talked about what? Concrete. When you go to concrete, concrete also has its own behaviors. If you go back to concrete, concrete is here. Concrete is one of the most useful materials that we make. It is made by adding sand to gravel and cement. That's concrete. So concrete we make, it has actually they are the strongest if concrete is allowed to dry out slowly. That's the only property it has, that it is strong if you allow it to dry out slowly. If you add sand, cement, and the stones plus water, little water, and you make them dry up, that is what they form. So let's go back to our point of discussion here. Here, they are saying the properties are very different from the properties of concrete and ceramics. So it is not surprising that the molecular structure, you see down here, this is what we call the molecular structure. There are two types of structures. We have molecular, and then the what? The electronic configuration. Those are two different things. So here we have what we call the molecular structure of substances. You add these elements here, two of them. This is ethene. It is an organic compound. When you add very many of them, they give us a structure called polythene. This is a molecular structure of polythene. Very many ethenes combined together. 1, 2, 3, 4, 5, 6 of them. Actually, ethene has 2. So these 2, you add another 2, you add another 2. So these are 3 ethenes combined together to give us a molecular structure of polythene. So when you look at this, molecular structure of plastics is also very different from the structure of ceramics. You look at ceramics, you find the pot. When you come to polymers or plastics, we see the structures as this down here. So here they are saying some atoms, particularly carbon atoms, can join together in a long chain. So if you get like these red things, the red dots here represent carbon. Everywhere you see is carbon. So even our bodies, inside our bodies, the main element we have is carbon. So joinment of carbon, the many atoms of carbon, when join them together, gives us that structure we see down here. These long chain molecules are called polymers. The long chains here, this long chain we are seeing, is what we call as a polymer. So now, poly means many, polygons, many. So many, and the polymers are compounds that are made of many small molecules joined together to form one large one. So the one large one is what we call a polymer. But if you join many, so these many small molecules are what we call monomers. Mono means one. Monomers, it comes from the word, if you remove poly from here, the mass remains. So if you replace poly with mono, it means mono is one. So if you add up many smaller ones, they give us a polymer. That's one large one. So one large one is called a polymer. If there are many, they are called polymers. This is a diagram. This is shown in the diagram below. This one is hydrogen. The black one is hydrogen here. Then the red one is carbon. So ethene is an organic compound with this structure. See, there are 2 C's for carbon and then 4 hydrogens. So a simple way of writing this is C2H4. So if you combine many of them, we don't know the number, we can call it N. So at the end of the day here, we shall form as many as this, and the name becomes polythene. The more you elongate, the more and the more longer that polythene becomes. So here they are trying to tell us the formation of polythene, that this is a very common plastic. Polythene is a very common plastic. Anywhere you go, it is there. They use it in shops where, so it is made from small molecules of a gas called ethene. Ethene here is a gas. So you may wonder how smaller molecules of a gas can be used to make a plastic that looks like that. First of all, what judges this is the thickness of that polythene. If you see the thickness of polythene, it is very small. Therefore, smaller molecules of gases, those smaller molecules of gases, the monomer for ethene, polythene is ethene. So if they become many gas molecules of ethene, they give us this polymer called polythene. So you can either call it polythene or polyethene. The pronunciation doesn't matter as long as you know the end product. So the main element in most plastics is carbon. That is the main element in plastics. Atoms of carbon join together to form chains. It can either form a chain, it can be branched or straight. These are joined to atoms of other elements, particularly hydrogen, that can be thousands of atoms in each molecule, like this one. It can be as long as 1,000 carbons, and then the number of hydrogen joined can also be many. So they are joined together by this, they are held together by this strong force. This one is no longer adhesion and cohesion. When we started this, we also looked at the difference between adhesion and cohesion. Now, there is this force called covalent bond. Have you ever heard of covalent bond? Unmute. Unmute. Have you ever heard of covalent bond?
No.
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 Now, what of adhesion and cohesion?
Yes.
You have ever heard of adhesion and cohesion?
Yes.
What is adhesive force?
Yes.
What's the adhesive force of attraction?
Adhesive force. Adhesive force of attraction.
Aya. 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 Rosemary.
Yes.
You tell me what is the cohesion force. As Austin is telling us what? Adhesion force.
Me? I'm just trying.
Yes, try. Try is better than nothing.
Me on my thinking, I think adhesion force is the attraction between 2 points.
That is Austin. Rosemary. Cohesion. Rosemary, cohesion force. Yes? Aya? Aya?
Yes.
You were there when we talked about adhesion and cohesion force. What are they? You don't know?
That's forgotten.
Aya.
Yes.
Now, we looked at water, isn't it?
Yes.
We took an example of water and glass. If you pour water in the glass, yes?
Yes.
If you pour water in the glass and you try to pour that water away, some water molecules will remain on the sides of the glass, isn't it?
Yes.
What is the name of that force holding those water molecules and the glass?
Cohesion.
Cohesion force.
It's cohesion force.
What about
Cohesion force.
What about water molecule itself? When you pour a water molecule down,
Adhesive force.
adhesive force. Okay, let's look at them here. And then you will judge for me which one. Now, here, they are saying cohesion is the intermolecular attraction force acting between two adjacent portions of the substances. Yes? Okay, that is two. Let me look at this. Now, this is what? This is a force of attraction between molecules of the same substance is called what?
Cohesion.
Cohesion force. Which now let's look at water. If you say water inside water molecules also molecules only. When you pour water molecule down, it always tends to be oval in shape. That means there are forces inside there holding the water molecules together. Which type of force is that? Yes? Is it cohesion?
Adhesive force.
That is cohesion.
It's adhesive. Cohesion
Okay.
force.
Austin.
Yes.
Now,
Yes.
inside, now inside the water molecules. Now, that's what they say, molecules of the same substances. So inside water molecule, we have cohesive force, not adhesive. Now, forces of attraction between molecules of different substances is called adhesive. They just adhere to each other. That's what we call adhesive. Now, a glass is different from water. The force holding water and the glass is called what? Is called what?
Adhesive.
Adhesive force. Now, if I ask for that definition again next time, and you fail to give me the answer, don't tell me you have forgotten. If you have forgotten, you can remember the explanation we have given. Is it correct?
Yes.
Okay. So this is a Mika or Mika? Mika,
Yes, teacher.
how are you?
Yes, teacher.
How are you?
I'm fine.
Okay. Thank you for coming. We are going on. We are still strong and lively. Okay. Now, I want to show you this force. It is called what? Covalent what?
Bonds.
Covalent bond. Now, there are two types. There are two types of bonding that we know. Mostly, though there are other types also, but the most common ones are two. They teach in chemistry. One is called the ionic bond. Then the other one is called covalent bond. Okay. My camera has failed to my camera is not allowing me to write, but now let me use this platform here to do the work. Here we are talking about ionic bond. When you talk about ionic, when you see charges in maybe a battery, all charges. How many charges are there on the battery? The ones that you know. Hmm? Hmm? The charges that you know that on a battery.
What is that?
The charges that are there on the battery. From P7, they tell you that a battery has how many charges? There are only two, isn't it?
Yeah.
We have the positive and
Two.
negative charge. Now,
Yeah.
if something has a
Negative.
if something has a positive charge and combines an element that has a negative charge, one of them has to lose electrons. The positive ones normally lose. Okay? The positive ones normally lose to the negative ones because the positive ones are heavier than negative ones. So when it loses to the positive ones, they form an element. You get? Now that element formed is what we call, it is formed due to that force called the ionic bond. You get? It is from positive to negative.
Yes.
Okay? Now with the covalent bonds,
Yes.
it involves sharing of electrons. I contribute, you also contribute. We come together and form one element. That one is what we call covalent bond. We share electrons. Okay? Is it clear?
Yes.
So when they talk of
Yes.
covalent bond, you just know it is a force of attraction between, actually it is a bond formed when two elements share electrons. Whereas ionic is formed due to, as a result of loss and gain of electron. One loses, another one gains. Is it clear? Yes?
Yes.
Okay. So here we have this. So they can be thousands and are held together by a strong covalent bond. Covalent bond is due to sharing of electrons. They share some electrons. So one element like carbon brings electrons. They share it with hydrogen and many other elements to form this element called polythene. Okay? So here they are saying polythene is a cheap, flexible plastic, and so it is useful for shopping bags and many other items. But it is not very strong. That is the only disadvantage it has. It is not very strong. Other polymers such as nylon are much stronger, but they are more expensive. Hmm? Yes? Others like polycarbonate, these are many carbonates
Yes.
combined together. If you combine many carbonates, you form what we call polycarbonates. So others such as polycarbonates, that your plastic ruler is probably made of, are stiff but can easily be what? Broken. So now you know what your plastic ruler is made of? Hmm? The plastic ruler you use is made of what? Hey, Joshua, you are the one writing on our screen. So the rulers we use are made of these polycarbonates. Carbonates combined together give us that plastic ruler. That your plastic ruler is probably made of are stiffer. So when something is stiff, it is quickly broken. Okay? So the difference in physical properties of plastics can be explained by the structure of molecules here down. So these are polymers made from figure 4.61, these ones here, then 4.67, and then this is one example of the structure here. So another one is down here. There are these ones. So this one is what? The image you are seeing here is for what? Hmm?
Fishing net.
Fishing net.
Ropes.
Which element they use for making it?
We use ropes.
Is it a rope? It comes
Yeah.
from a material called nylon. You know nylon?
Yes.
Yeah. So nylon, they add on these corks. What is the use of the corks? Huh? One side of a fishing net, they put these corks, and then the other side they put what? Stones. What is the use of these corks? Hmm? To keep the net on top, to keep the upper part of the net floating, isn't it?
Yes.
So that is the use of that. So this is a polymer chain made of nylon. This one. The way it looks like is this dotted structure here. So these are the corks fused together with nylon to give us a fishing what? Net. When this session gets over, okay? When the session gets over, you can rejoin using the same link you used.